Hello everybody, and thank you for being here in this big event, which is BIM Coordinators Summit 2023. I'm so delighted to be one of the speakers of this event, and a special thanks to Mr. Ralph, Emma, and all the team members who did a really great job and great efforts organizing this event. I'm Maria Roberta Rotondo. I'm a digital lead for AECOM Italy, BIM manager and senior architect. I'm also a member of the Women in BIM as a mentor and a RIBA chartered architect in the UK. I'm an architect registered architect to the English order and Italian one. Today I'm talking about quality. I chosen this topic because sometimes we are under pressure with high deadlines and we are underestimating the importance of the quality control. From the beginning, since we start setting up the project and when we start gathering information. So I'm going to speak about these contents, the definition of quality, the quality control before and after BIM, which are the advantages of BIM in terms of quality. We will talk about quality as a critical aspect in the BIM process. I will show you a very brief step-by-step workflow we can follow, and in order to follow the BIM quality control and the model checking, and we will see a BIM checklist and then a conclusion. Let's start from the definition. What is quality? As defined by the ISO 8492, the quality is the totality of features and characteristics of a product or a service that bear on its ability to satisfy stated or implied needs. Well, we know that we can distinguish in quality assurance and quality control. Which is the difference? The quality assurance primarily focuses on the processes and procedures that improve quality, including trainings or documentation, monitoring, audits. Quality control instead focused on the product to find the issue that can remain after the development. Before describing more in detail what is the quality in the BIM process, I want to tell you about a personal anecdote that happened during a meeting. We were with the managers of the team managers, and we were just showing a model of the project. There were a few problems with the quality of this model and the representation of it. So it was that meeting was before the meeting with the client. That was a very important meeting, and one of the oldest managers, the senior manager in the room, was telling about this story about Kaoru Ishikawa. Since that moment, I honestly started thinking more about quality, and I thought that sometimes we need to focus much more. That's why I chose this as topic of this presentation. Kaoru Ishikawa was a Japanese organizational theorist and professor in the engineering faculty in the University of Tokyo, and he was noted for his quality management innovation. He was considered, is still considered, as a key figure in the development of the quality in the Japanese industry and on the initiative in Japan. So it was called after the Second World War because Japan sought to transform its industrial sector. Japan at the time was considered like a producer of low quality products, so the quality was not one of the main targets of Japan after the war. And if you read this sentence from his book that I read, it's quite true. So when we talk about quality, sometimes it can sound quite obvious, but it's not like that. It's something that we need to focus much more about. And he said, I strongly urge readers who learn about QC through this book to put into action. Theory and scholarship are also needed in QC, but it only yields tangible results if practiced. Some readers may think that what the book says is obvious. They are right. Before QC, what should obviously have been done inside and outside the company was not either not being done at all or only being done piecemeal. An alternative definition of QC could in fact be everyone doing what should be done on an organized and systematic way. I'm not a digital native, and we are all BIM professionals, so most of us know that before BIM, the control of the quality was really an issue. We cannot achieve the quality control we can today with the previously traditional method of designing. So I'm thinking about AutoCAD. I'm thinking to find to do the 3D model in AutoCAD. Finding clashes, no, we didn't do that. We just were unaware of some of the clashes until we were on the construction stage. So we all knew it. I'm not saying nothing special in this moment, but it's just to understand how the quality control is important and is actually changing the way we work since the conception phase to the completion, because all the problems and the issues that previously were not identified and resolved before the construction stages were a problem during the construction phases. I think about clashes between disciplines, between MEP or structures. So we can find now these issues, we can solve that before going on the construction site. So we all knew how with BIM the importance of the construction stage is to identify and to resolve the issues and to check the quality, to control the quality in several ways, as I will show you later, because it's not just a matter of clashes and code checking, it's much more. So, which are the advantages of using BIM in terms of quality? First of all, we work simultaneously. We can do that. We can work from the other side of the world on the same model. That's amazing. I do it very often in my company. I used to work with South Africa, with Romania, with Poland, sometimes with US, and that's incredible. We can work in the same moment on the same model. That was not possible before with traditional software with AutoCAD. We were just saving many times the file with several naming at the end, just to distinguish the first version to the other one. We didn't have any naming convention, so we actually are improving, first of all, the collaboration between disciplines, and then we are increasing precision, efficiency, with more accuracy, reducing errors. I was just mentioning before the clash detection and the importance of the model health. We are improving collaboration. We are coordinating the discipline. We are coordinating also the material that we have, the documentation, what we got before when we are gathering all the data. That's the key word, data, because now we are working with data. And what we are delivering is not just a designing project, we are delivering data, we are delivering information. We are delivering something that can help the building to be managed and more sustainable during its life cycle. That's why with this software we can also improve performance and do simulation for energy for sustainability purposes. We can reduce the costing providing bill of quantities, and we can reduce maintenance costs and time providing information to facility management since the earlier stage design. We can do this and much more, because when you are involved in a project, you can find much more issues, but the possibility to work with more discipline to understand that the issue, again, in the design stage earlier can save money and can save time and reduce reworking. That is not very nice. Quality is a critical aspect in the BIM process. It means conformance to specification. Conformance at the model level is a subset of the overall quality definition. Model quality means conformance to requirements. That includes level of details, procedure, specifications, accuracy of the building information model geometries. Conformance is the ability of the model to meet its BIM specification and to meet what are the customer needs, the constructor needs, and the design team needs. Then we have accuracy and completeness. High quality BIM models should accurately represent the physical characteristics of the project. This includes accurate geometry, dimension, and properties of the building elements. The model should be also complete, including all the relevant information, all the information required for the design, the construction, and for the operation. And overall, we are still talking about data. As I mentioned before, we have data, we have information. And the accuracy of this information should start from the beginning of the project. When you are gathering all the information of the project, the quality starts from the very, very beginning, the very early stage. Then we have the information consistency. This is a very important point because BIM promotes the consistency across the different disciplines, across the different project phases. All the stakeholders should have access to the same reliable and up-to-date information, reducing errors, conflicts, and misunderstanding. Maintaining data consistency is crucial to ensure the quality of the BIM process. And then we have clash detection and coordination. This is maybe the step that we all know about quality, and maybe someone thinks that the quality check can just reduce to this part. No, it's not, as I can show now, it's not like that. This is just a part of the quality check, the quality control process within the BIM. The clash detection and coordination is a very important point. Allows to identification of clashes, the conflicts between the building elements of the different disciplines, identifies conflicts, identifies clashes, and we can solve these already in the design stage before going into the construction one. The most important thing in this stage is not only to identify the clashes, but also to coordinate and resolve them, to assign them to someone to sort them out, and to identify someone that's control again, double check again if these conflicts are not anymore there, if the model is held, it doesn't have any conflict, any clashes. This is very, very helpful, this check, because it reduces the rework, delays, and prevent from costly reworks, delays, errors during construction, leading improved quality and efficiency. The standard compliance. The standard compliance is very important because BIM involve adherence to specific standards and protocols, and it's like such the IFC, for instance, that is the model that we use to ensure the interoperability between all the actors that are playing in this project, that are working in this project. Following this standard, the quality of the BIM process facilitates the collaboration among the project participants. Again, collaboration and communication. All these points are connected one to each other, and the collaboration and communication is the fundamental of the BIM. It's something that, as I've shown you before, when I was comparing before and after BIM, even if you were having a team very collaborating and communicative before BIM, it was not enough to ensure the collaboration as we mean with BIM. Collaboration simultaneously, collaboration with an assigned task to do in this another process that starts from the beginning to the the end of the design stage in the BIM process. So BIM encourages the collaboration, the communication among the project stakeholders, including architects, engineers, contractors, facilities management. The effective communication and information is very important for the project life cycle. It contributes to the project life cycle quality, improving the quality and the better decision making, the issue resolution, the inclusion of diverse perspective. Then we have documentation and record keeping, and BIM is the way to generate and manage a documentation through all the project life cycle. This includes design documentation, construction schedules, material specifications, maintenance information. The well-documented BIM models provide a comprehensive record of the project and is an help for the future maintenance of it. And then continuous improvement. This is very important because all of us are learning from previous projects. The BIM is not such a static thing, but it's a dynamic one. We are always learning, always improving. Every day we have a new tool, a new software, a new plugin to accelerate, to make our action quicker, but more efficient as well. So the continuous improvement comes also from the previous project we do, from the lesson, the lesson learned from the previous project, from the performance analysis, from the feedback we got also from the client. So the focus on the continuous improvement contributes to the higher quality outcomes in the future projects. We need to set up the model following a step-by-step workflow. The first thing is to base all the model, all the information that we got from the BIM execution plan. That is the most important document where we find all the information and where we can find also the organizational chart, where we can find roles and responsibilities for the coordination of the model. It's very important now to set up which are the goals, what is the scope, which are the targets, which are the templates we need to use for each discipline, who is responsible for what, which are the roles within this model, who is the specialist, who is the modeler, who is the coordinator, who is the manager, who is the people that is verifying and doing the control check and the quality control check on your model. And then we have the phase of the detailing where we are adding information. Again, information, size, shape, materials, everything is in this phase of the model detailing. And then there is the model checking. It's important to set up the timeless internal deadlines to check and to control and to track and to monitor all the quality process within the model and the design phase. We need to track the coordination performance with a BIM checklist, with a model checking. How can we do that? We can do that in an organized and systematic way that can ensure the quality through the whole life cycle of the building. Again, for the checklist, it's important to define targets and scope. It's important to answer responsibilities while doing the check in order to track and to control and to assign eventually the issues to these people. Set up a timeline with to complete each task of the quality control checklist. Monitor and track the progress on the quality control checklist and ensure that all the tasks are completed on time and to a high standard. The BIM checklist is a tool. It's a tool that will help you in creating an organized process and will assist you and your team to maintain a good design habit within the project team, following simple steps in a quality assurance process, among other things. You can identify quality issues that may impact on the objective, on the quality, ensuring model design validation, formulating appropriate responses to these issues, to quality issues, controlling the implementation of the responses that we have, minimizing errors, reworks, by ensuring that each individual performs their duties in a systematic manner, utilize approved, documented procedures and work methods for checking and verification of deliverables, ensuring limited wastage of materials, saving costs in construction. The BIM QA/QC checklist will help to streamline the quality check process. Depending on your project, the checklist may change slightly from project to project. It is important that you tailor your BIM QA/QC process to the specifics on the project rather than passively follow someone else's list. It is important that you understand which are the disciplines that are part of your model, which discipline you have to control, which one deserve a separate control or particular control. It depends from the project. So it's important that you consider that the checklist may change from project to project. Also, it's important to consider the final model revision, making sure that all the issues have been identified and resolved. To sum up, we have 4 keywords: planning, working, checking, and deliver. Planning, because since the beginning, at the early stages, we need to have all the accuracy of the information consistency, accuracy of data, and all the information we know are contained mostly in the BIM execution plan that we need to follow in order to have the most accurate model. Then working, collaboration, communication with other stakeholders, with the other disciplines. That is the key to work in a good manner, good way. Clash detection, coordination. This belongs to the checking. It's just a part of the checking, we know, but it's the most important because it comes after the working. And then deliver. After deliver, improves from lesson learned. The key is to have a clear path and make strategy and structure the way you pursue quality from the planning stage of a job to the end of the construction to guarantee quality in the facility management of the building. Never assume model quality check will happen by itself. Check your models, otherwise all the benefits sold under the name of BIM will never pay off. Thank you for your attention.